Hello peeps! Here we are with the virtual version of the force table. And so we're doing this online, which actually worked out pretty well. There's this site called MrWaynesClass.com that has a bunch of simulations for physics activities, and it works perfectly for the force table. It begins with some background information about adding vectors together, and you can see animated over here is our vectors that are added together, and the red represents the resultant. All right, so by adding them tip to tail, we find the resulting magnitude and angle if we were to have a protractor and measure it. This is an actual force table, so we'll be able to see this in class as well. But basically it has this system of pulleys and weights, and the object is to center the ring. You're given 3 pulling forces. You have to find the one equilibrium force that will balance it out so that the ring surrounds the post but does not touch it. So it's a nice little game, and here's the top view of that. So we're going to go to the actual simulation part. Clicking at the bottom down here will bring it up. Here we go. So we're waiting, and there it is. It's a Flash applet. And there's some background information about it, and also some zooms, pictures of the force table in action. We're going to click and go right to the simulation. So you see here that there are 3 forces, and they're pulling on the center. Now, one of the things about the simulation is that it does not represent the magnitude of the vector in terms of the size of the arrow. These arrows are all the same size, but that's not true about vectors. Vectors should be, ideally, especially when you're handling them graphically, they need to represent the magnitude. So the 391 should be the longest, 339 the middle, 167 should be the shortest one. Right now it's just representing the direction as if the string were pulling through tension on the center ring. Okay, so we need to be mindful of that when we model this in a program called, well, GeoGebra. Here's GeoGebra. All right, so we're going to go over here and use it. We're going to set up GeoGebra and then come back. So the first thing we want to do is show grid, because we want to see all that great stuff. All right, it's easier to work with graph paper, okay? And rather than just the basic tools, we want more. We want more tools. So it gives us things like vectors and angles and other sorts of great things, and the ability to bring in media, okay? So I'm going to go back now over here. In order to work with this, I need to take a picture of what's going on. Later, we'll use this tool over here. See how it turned yellow? Okay, so it's the innards. It's this little ring over here, this angle tool. And if I click, drag it, I get round, you can see that the measurement of degrees is going to be given. It's relative to this position here at 3 o'clock, and it is counterclockwise in terms of degrees. So we've got 0, at 12 o'clock is 90 degrees, at 9 o'clock we've got 180 degrees, and at 6 o'clock it's 270 degrees. All right, so that's going to be our system for angles around this circle. All right, and we're going to eventually measure these angles. It's not important yet, but when we check our answers at the end, we'll do that. So what I need to do is take a screen capture of this. So I've got a Mac, so I just hit Shift Command 4, and I got these crosshairs over here. I'm going to click, drag around so that I have that circle contained. All right, boom, I have it. You heard maybe the little picture sound. And if you have Windows, you can either use the snipping tool or Alt Print Screen. You can bring it into Paint. All right, so the next thing is to go into GeoGebra, scroll down over here, click on Media where it says Image here, and that will allow us to choose the file that we want. I've got a lot of screenshots, so I think this is the one. Yes, it is. Choose, and it's over here. Now it's part of my landscape. All right, so it's on the grid, which is fantastic. That's exactly what I want. All right, and I'm gonna leave that alone. But the first thing I need to do with it actually is to click on the image and settings. I did right click it, but I think you click either way. Go to color, and I want to reduce this halfway, the opacity about 50%. That way I can see through it. I can see the grid, so it just makes it a little bit easier to position. Okay, so I'm going to X out of here, and I'll try to get the center now perfectly aligned. You see, I can see those dotted lines align with the grid. All right, so this is working out pretty well there. Okay, what I want to do is create 3 vectors that represent these, but I'll do it to scale. So I go here in the lines category, all the way to the end are vectors. So I click on that, and I'm going to go start from the center, and I'm not worried about the size yet. I'm just going to get the angle correct first. So here it is, because I don't know the size. It unfortunately doesn't give it to you automatically unless you ask for it. In order to get it, you got to go to Measure, Distance or Length. So I'm clicking on that. and I'll click the 1, 2 points that bound that vector together. It says 17.6. All right, 17.6 centimeters is what it would be. I go back over here to basic tools and move. Now I can move this all around. And I'm going to scale this at 1/10, right? So this is 339 newtons. I'm going to go for 33.9 on this chart over here. So I'm going to stretch that out, maintaining that angle. And 33.9. Oop, too far. 33.9. So I'd imagine when you're actually watching this, the nice thing is that you can fast forward or just replay anything you need. So you don't need to see all the little tedious stuff, but I've got to talk it out. So here we are. All right, so there's one vector. What I'm going to do once I have it is I want to move it out of the way because I notice weird things happen. Every program has its idiosyncratic behavior, and when I place another vector and attach it, it wants to stick and I can't get it off. So I just want to move that vector out of the way and do the next one. All right, so the next one here, 39.1 is what I'll go for, rounded down. So back to vectors, I click and I stretch that out like so on that same angle. Yep, that's looking good as I zoom in. Now I'm going to go to measure, click the 2 points. I have to click the 2 points. 1, 2, there are my 2 points. I'm 33.8 and I need that to be 39.1. So I'm just going to stretch it out a little further, go back to the basic tools and move. And I want to make sure, let's see, 39.1. I'm at that angle. Yes, it's good. It's at the same angle. All right. So I move this vector now, move it out of the way, and we got one vector to go, the 167.5. Now, the way I'm zooming here, I can zoom with the tools at the bottom right, but I have a mouse with a wheel, and the wheel going forward for me zooms in and going back zooms out, so it makes it pretty convenient just to kind of zip around here. CAD people are probably really familiar with something like that anyway. All right, vector, point, and got my angle, click. All right, that looks good. There's my vector. Let's get its size. All right, points, boom. All right, 23.1, that's too big, so I want, actually I'll round it to, let's see, 116.8, because that's round the 0.5 to that, since we're only at the, tenths place here, so here we go, 16.8. Let's get it, let's get it. Let's get it. There, I got it. Nice. All right, so we got our 3 vectors. So now the idea is that we want to add them vectorially, which means tip to tail. It's the arrangement, all right? So I'm going to move this guy out of the way over here. And I can start with any one of them. It doesn't matter. Remember, the order when adding vectors doesn't matter. As long as you add them tip to tail, you're going to be fine. So I'm going to start with, what the heck, with C as the starting point. And we got D way up there. So let's add this vector. So I'm going to connect E, which is the D, which is the tip, and the tail of E together. All right, that's a pretty big spread. All right, now we're going to go from G, which is the tail, to the tip of F, like that. All right, and so here it is. We started at C, we ended up at H. So the vector is along this C to H point is what we want to connect. That's the resultant. So I'm going to create one more vector as the resultant from C to H. And there it is. I'm going to click on it. Too many vectors, undo. Okay. Basic tools, click on it. And I do want to change its color so we can recognize it. Okay. So in these 3 dots over here, go to settings, color, and we'll make it, bold red so you know it like that. All right, so here it is. That's our resultant. Let's get its length. To do that, I go to measure, distance or length, C, H, and we got it. All right. Now the problem is, like I told you, things get screwy if you connect things together. If I try to move this now, all right, so go with the move tool and move it, it's going to mess with everything else. So I don't like that. So what I can do is this though. I'll click on it and duplicate it. Just make another. As long as they're parallel, you can move them all around. It's still the same vector. All right, so that's the nice thing about it. So I will position this on the grid like this, and its magnitude is 62.8. So in terms of what we're doing, remember that's 1/10 scale, so it's about 628 newtons of force is what it represents. And we also need the angle, all right? So the angle here is relative to that 0 going all the way around 360 degrees. Now we go to the angle tool here back in measure, and you need 2 points in a vertex being the connecting point between them that makes like the V shape. So I've got 1 here, 2, the vertex, and another point. And here's the angle. Now it's hard to read, so I'll drag it out. Here it is. Angle is 27.3. We'll call it about 27 degrees. All right. So the thing is, this is the equilibrium. Actually, not the equilibrium. This is the resultant. Equilibrium is 180 degrees on the other side. So all these three poles, these vectors are pulling in this direction at 62.8 newtons, approximately 27 degrees. But we need a force that's 180 degrees opposite to balance that out. Okay, so that's what we're going to do. In order to do that, we take 27.3 and we'll add that to 180 to figure out what the angle should be on the other side. All right, so we do that and we get, let's see, 207.3, so about 207 degrees. We'll do it. Okay, so I'm going to go back over here, and this was about 60. Oh, well, we should go back and look, shouldn't we? We should make sure. 62.8, so 628 at 207 degrees. So 628 at 207 degrees. So that should be fine. Now, if we're right, we'll know it. If we're not, we'll hear it. All right, that's great. What if we weren't so right? Just put any random value there. Yeah. So you'll know when you're right. So you want to take a screen capture when you have this successful. So, oops, that was 628, right? Check your answer, and here we go. All right. We're in business. Now, what I want to show you is that we can check these values another way. And that way is by using the vector addition calculator. So here it is. It's a link that I've also provided. And you can just put in up to 10 vectors. You can put their magnitude on, and directey. So see, here's what I did. I did the zoom thing, right? So you can read it a little bit better. So how do you like that? It says something weird. All right, magnitude and direction, but I want you to be able to see stuff. So now we have magnitude and Dioxetian. Okay, let's go back to our original piece over here. So we can check this numerically before we even do anything. But I want the graphical technique is what we're all about, so we want to see that. But you can also check here to see if you're on the right track. All right, so we're at 339.1, and let's see what the angle is. So I move this over here, right, and look at about 43 degrees. All right, at 43 degrees, and 167.5 looks like the angle is over here at 116 degrees, right? 167.5 newtons at 116 degrees. Lastly, that's our resultant. We just want this one over here at 391, all right, 0.3. Now our other result was a little bit rounded, but it still gave it to us. It knows that we're going to round if we're using graphical techniques at 347 degrees, okay? Now, I'm just going to plug those in over here, and we should be able to see some magic here. So we got 339.1 at 43 degrees. We got 167.5, and that was at 160 degrees. And then 391.3 at 347 degrees. Calculate. Here we go. So what we have is our 628 newtons. Okay, so that was cool. 628.7. And remember, this is the angle that we found, about 27 degrees. We added that. We added 180 to get the equilibrium, which is on the other side. All right, so this is the right answer, and that checks out with exactly what we did. So that's it. That's what you got to do. So please take some screen captures. By the way, I just want to show you a quick feature within the GeoGebra, is that you can go over here and you can register and all that kind of stuff, but you don't have to. You can go and download as PDF. Download as PDF. It'll export picture. So we've got force table lab export like so, and then it will do it all for you. All right, boom, there it is. Okay, so thank you much. I hope this helps. Look forward to seeing these labs. Morad out.